Now let's talk about other category, constraint optimization methods, and what it includes. The first one is linear programming. In this method, you look towards reducing the project cost by efficiently reducing the duration of the project. You look for running an activity in its normal time or the crash time. The crash time of the activity enables you to reduce the activity time of the project as a whole. For example, if the activity doesn't lie in the critical path of the project, then you might not want to consider crashing the activity, right? So critical path of the project is the sequence of these activities that you need to perform from start to end, considering that you can perform other activities, which can be another sequence of activities, in parallel, for example. You can find a video on my channel about fast tracking and crashing for more details. The next one is integer programming. In this method, you look towards a decision that works on integer values and not on fractional values. For example, producing a number of cars can never be fractional. In contrast to the linear programming method, where you work on a continuous model that enables you to define decision variables to be fractional, in the integer programming model, you must consider only integer values for the decision variables. The next one is dynamic programming. This method provides a general framework of analyzing many problem types. In this framework, use various optimization techniques to solve a specific aspect of the problem. This method requires your creativity before you can decide if the problem needs to use dynamic programming for its solution. This method of project selection is a mathematical technique to make a sequence of correlated decisions. The method consists of systematic procedure to determine the best combination of decisions. In the linear programming method of the project selection, you have standard mathematical formulas. However, in case of the dynamic programming method of the project selection, you do not have any standard mathematical formulas. The next one is multi-objective programming. In this method, you make decisions for multiple problems with mathematical optimization. There are multiple terms used to define multi-objective programming, such as multi-objective optimization, vector optimization, multi-criteria optimization, and Pareto optimization. This method actually is an area of making decisions based on multiple criteria. You make decisions mainly based on mathematical optimizations of problems that requires you to simultaneously optimize more than one objective function. In this method of project selection, you make an optimal decision in presence of a trade-off among multiple conflicting objectives. For example, minimizing costs, maintaining quality control, and adhering to deadlines are common multi-objective optimization problems you face in most of the project. Okay guys, now we will talk about economic measures for project selection.